On Suelo yet again, mathletes. It's a great day to be a mathematician. Okay, what we're going to do is kind of look at quadratic functions and just answer a bunch of questions about them. We should be able to look at something and say, okay, what does this graph mean? We're going to graph it and then say, okay, let's read the graph. All right, so let's make, again, this is standard form, so let's make the graph. So we're going to find the vertex. So we've got negative b, which is -1, all over 2 times a, which is -1. We got -1 over 2 times -1, which is 1/2. And then we'll plug in 1/2 into the equation for x. We have negative, and 1/2 squared is 1/4, plus 1/2, and then plus 2. Okay, so you can call that anything you want, but it's basically 2 1/4. If you want to call it, 9/4, be my guess. Okay, so let's make a sketch here to see what we want to do. So we have 1/2, comma 2 1/4. So it's somewhere around here. We'll put the axis of symmetry through it. Now, when you make the points, I'm going to pick the ones, again, closest to the x-axis. It doesn't have to be like exactly 1 away from the half. So you don't have to pick like -1/2. Just what's the nearest integer? And I'm going to go to the left, but you could go to the right if you want. What's the nearest integer to 1/2? And that would be 0. And then what's the nearest integer after that, to after 0, and that would be -1. Okay, so let's plug in 0 into the equation. If you plug in 0 into the equation, hopefully it's obvious that the answer is 2. If you plug in -1, you get -1 squared plus -1 plus 2. Okay, so you square the -1, giving you 1, make it negative, that's -1. Plus -1 plus 2 gives you 0. Okay, so now, we're going to have 0, comma 2, something like about there. And then -1, comma 0. So we'll have the other points like over here. Okay, so what would those other points be? Well, if this is at 1/2 and this is at 0, the one on the other side will be at 1. So that would be 1, comma 2. That'd be the symmetrical point. And if this one's at -1, then it's -1.5 away from the axis of symmetry. So if we go if we go 1.5 away on the other side, that would be positive. Gosh, I can't even think. Okay, so we're at 1/2, and we're going to go 1.5 away, so that'd be 2. And that's going to be 0. Okay? All right, so let's see. We've got, and we'll just go by ones here. So we have 1/2, comma 2 1/4. Just do the best you can. Okay. In my case, isn't very good, apparently. Okay, we have 0, comma 2, and its symmetrical point is 1, comma 2. And again, remember your axis of symmetry is here. Okay, and then we have -1, comma 0, and 2, comma 0. And then we'll draw the graph. Again, as best you can. In my case, it's usually not too good, but make sure you're drawing a curve. Okay, now we just want to answer questions on this. Okay, so and I'm going to probably have to flick back and forth. What's the domain? The domain is -infinity to positive infinity. This is not a new idea. We've been finding this since chapter 2. What's the range? Remember, you start at the bottom and go up. Don't go top to bottom, but start at the bottom. What's the first y value you hit? -infinity. What's the last y value you hit? 2 1/4. Does a graph have a minimum or maximum value? This is new. We've never dealt with this before. Okay, so what am I talking about? Take a look. I'm just going to sketch something, but just listen. Take a look at a curve. And I know it's not that one, but, parabola. Okay. Somewhere, there's got to be a largest or smallest value on this graph. Well, let's take a look in the x direction. Does this graph ever stop going to the left? No. So it has no minimum x value. Does it ever stop going to the right? No, it's always going up to the right, so it has no maximum value. So in the x direction, a parabola is never going to have a minimum or maximum value because it's always, take a look at the domain, negative infinity to positive infinity, right? How about in the range? Does it have a, sorry, I shouldn't have said that because that's not this graph right here. Let me just sketch this graph. Let me get rid of this thing. I shouldn't have used that example. Okay, so the graph we're looking at looks like this, right? Okay, does it ever start going to the left? No, there's no smallest x value. Does it ever stop going to the right? No, there's no largest x value. Its domain is negative infinity to positive infinity. Obviously, there's no smallest x or smallest y. Okay, does it ever stop going down? No. If you take a look, this thing down here, I just kind of re-sketched the actual graph just to kind of look at it without worrying about the grid, okay? No, it doesn't. So there's no minimum y value. Does it ever stop going up? Yes, it does. It stops going up right here. Okay? So there's no minimum or maximum x values. Look at the domain. Negative infinity to positive infinity. Okay? There's no smallest or largest number. It just keeps going to infinity in both directions. In the range, is there a smallest number? On this particular graph, no. But there is a largest, and that's 2 1/4. And if you notice, that's the y-coordinate of the vertex, because the vertex was 1/2, 2 1/4. Now, is 1/2 a minimum or maximum? No, it's just one of many x values. It's kind of in the middle of all the x values. But 2 1/4 is the largest y value here. Your minimum or maximum value is always going to be the y-coordinate of the vertex. So does the graph have a minimum or maximum value? Which does it have, first of all? Is it a minimum or is it a maximum? You got to answer that first. And this graph has a top to it. It doesn't have a bottom. So if it has a top, it's a maximum. So this is not a yes or no question. You have to actually tell me minimum or maximum, okay? Now, what's the minimum or maximum value? That's the 2 1/4. Okay, now this question, number 5, is a horrible question, okay? I don't like this question, but I have to show it to you. Alex is going to ask it. Okay, where does the minimum or maximum occur? Well, if you were to ask me, where's the minimum or maximum occur, I would say 2 1/4. But that's not what it's asking. What it's asking is this. Now I'm going to move this up a little bit. What it's really saying is this. What is the corresponding x value for the maximum or minimum? If I didn't define that for you right now, I don't think there's any way you'd know it. I certainly know I wouldn't know it, okay? So what's the corresponding, where does the minimum or maximum occur? In other words, where in the x direction does it occur? And it occurs at an x value of 1/2, okay? Notice the minimum or maximum value is not the vertex. It's the y-coordinate of the vertex. Where the minimum or maximum occurs is not the vertex. It's the x-coordinate of the vertex, okay? And I apologize. I'm going to have to move this thing up so I'm going to move it up and down. I'm going to get rid of this picture because I don't really need it anymore. Okay. And of course, we could have picked that straight off the graph. Okay, what's the next question? What are the zeros? Remember I said the zeros are the values of y when x is 0. And even though it's not perfectly the same thing as an x-intercept, for now you can think of it as an x-intercept. So what are the x-intercepts on this graph? -1 and 2. Okay? So your zeros are x. I don't even need to put x. I'll just list what the zeros are. They are -1 and 2. They're not points. That's not a point. And they're not points. It's not -1 comma 0 and 2 comma 0. Okay? It's the values of x only where y is 0. Okay, well, what's the x-intercept? That's -1 comma 0 and 2 comma 0. Those are points. -1 comma 0 and 2 comma 0. Okay, what's the y-intercept? Well, if you look at the graph, the y-intercept is going to be 2, and it's 0 comma 2. What's the axis of symmetry? Well, what's this axis of the line of symmetry? It's a vertical line. What's the equation of every vertical line? We haven't done this for a while, but it's x equals whatever number it is. Well, what number is that? It's a half, right? Because it's the vertex is 1/2 comma 2 1/4. So what is the equation of the vertical line through that point? It's the equation of every vertical line is x equals the x-coordinate, so it's x equals a half. And do you have to actually put x equals a half? Yeah, you do. Okay? So all we've done is graph it and then answer these questions. All right, now I want to answer these questions for this graph. And that didn't copy too well, but that's a 2. Or for that equation. But notice, I never asked you to graph it. Okay? May you graph it? Yeah, but you don't really need to. All you really need, remember when I drew this thing up here and I drew it upside down, kind of apart from the graph itself, and I said, okay, your maximum's up there and that maximum is at the vertex. That's all you really need, is a sketch with the vertex labeled, okay? That's why I kind of did that, was kind of where I was leading us up to the second problem here. Okay, so what am I going to do? I'm not going to graph the whole thing. I'm not saying you can't graph the whole thing. You may. What I'm saying is you don't need to, okay? So let's find the vertex. And the vertex is going to be -4 all over 2 times 2, which is -1. And then find the y-coordinate. I plug it in. So we have 2 times -1 quantity squared plus 4 times -1 minus 30. Okay, so what's that? That's 2 minus 4 minus 30. So that's going to be -32. Okay, so what's this graph look like? Other than the vertex, all we need to know is, does it open up or down? And if you take a look, what do we need to know? You know, what tells us whether it opens up or down? The leading coefficient. The leading coefficient here is 2. So I know it's -1 comma -32 opening up. And again, you know, you have the axis of symmetry through it. Okay, let's answer the questions then. That's all we need. Okay, what's the domain? Well, pass your vertical line through it like we did in chapter 2. And it's -infinity to +infinity. Okay, the range, pass your horizontal line through it, bottom to top. And what is it? -32 to +infinity. Okay, does the graph have a minimum or maximum? Which one does it have? Well, it doesn't have a top. It's got a bottom, though, so it's got a minimum. Okay, what is the minimum value? -32, right? There's no minimum or maximum in the x direction, only in the y direction. There's no top to it, but there's a bottom, and where's that bottom? At negative 32. Where does that occur? At an x value of negative 1. Again, that's the corresponding x coordinate for the minimum or maximum. The zeros, now, how do I find zeros? I can't pick them off the graph because I didn't graph it. Doesn't matter. How did we find zeros a couple days ago? The value of x when y equals 0. So you set 0 in for y, and then you factor it. Now, when you factor this, we can take out a 2. Again, that'll make our lives easier. So that's x squared plus 2x minus 15. So that's 2 times x plus 5 times x minus 3. So what's that? That's negative 5 and 3. Those are the values of y when I substituted, the values of x when I substituted a 0 for y. Notice, by the way, I could have also divided out the 2. Now, be very, very careful here. I'm going to write something. Don't write it down. Just listen. The original equation was this. G of x equals 2x squared plus 4x minus 30. Can I solve that for x? No, I can't. Can I divide away the 2? No, I can't. Okay? Why? Because this is not 0. So when you find the 0, you actually have to put 0. Remember, what's the first thing you need in order to solve a quadratic equation for x? One side has to be 0. Can I arbitrarily just stick a 0 in there because it's fun to do? No. See, the problem asked me to do that. It said, find the zeros. It says, what does it mean to find the zeros? Find the values for x when y is 0. The problem told me to substitute in a 0. Don't just do it arbitrarily. You can't. Well, you can, but you'd be wrong to do so. Okay, the x-intercepts. Well, the x-intercepts are going to be the same thing as the zeros here, so it's negative. Again, there'll be a time when they're not the same, but we'll worry about that another day. So we have negative 5 comma 0 and 3 comma 0. Those are points. Those are values where the graph would cross the x-axis. The y-intercept, just substitute in 0 in the original equation, not in the one that's got the 0 equals 2x squared plus 4x minus 30, because there's no y in that equation. But in the original equation, which has y, you stick in 0 for x, and you get 0 comma negative 30. So I want to point out something. Notice up here in this first problem, okay, we graphed it and picked the answers off the graph. That's fine. Great. But you don't need to graph it. I just asked you to. But in B, I didn't. All you really need to do is vertex and which way it goes up or down. And then these other things you can just get straight from the equation. Axis of symmetry is x equals negative 1. Okay? So, that's it. So you should be, what's the only thing new I've told you here? This idea of a minimum and maximum. Okay, x of symmetry, we've looked at that. Y-intercept, we've looked at that. X-intercepts, zeros, domain and range. The only thing that's new here is this idea of minimum and maximum. Okay? So, I hope you've found this totally scintillating. Talk to you next time.